Yes students, welcome to our second part of the same lecture. Now we are going to do questions 3 and 4 to complete the section F. Owner of a factory decided to produce 50 mixtures used as household equipment, but the daily production of mixtures changes due to variation in the number of workers. Of course, on an average day, say workers are absent. A variation in production of mixtures with respect to pre-decided number of production 100 units during 40 days is recorded as error. Production was decided as 100 units, but sometimes due to less workers production is less, and sometimes if all workers are present, the production is more. Prepare an exclusive continuous frequency distribution. So we are told to go for exclusive continuous frequency distribution class 10(6) and mid value of one of the classes as 3. Also prepare less than type and more than type cumulative frequency distribution. So here we have to be space accurative. According to given what is XH and what is XL, highest is 23, I suppose, and lowest in a negative value is -10. So the range of the data is R is equal to XH minus XL, 23 minus -10, so it will be 33. Class length is given as 6. So number of classes which can be made are range divided by class length, 33 divided by 6, which is 5.5. So approximately I go for 6 classes. Mid value of a class is 3, and C into K, 6 into 6 is equal to 36, which is greater than or equal to R. So this relation must be always students satisfied. C into K greater than or equal to R. Students, this relation must be always satisfied. Now, mid value of one of the classes is given as, you can say, 3. So for that, all of you know this formulas. Lower limit is equal to mid value minus half the class length. Mid value is, you can say, 3. Class length is 6. Upper limit is equal to mid value plus half the class length. So 3 plus 6 by 2, so 6. So one of the classes is 0 to 6. Now students, let us go for the title Exclusive Continuous Frequency Distribution of Change in Daily Production. Exclusive Continuous Frequency Distribution of change in daily production of mixtures for 40 days. This is sufficient. Now, our first column will be classes, then tally marks TM, and then FI. Students, pay attention, because here we have to go for cumulative frequency distribution also. Now students, our next step which I am writing, students. Our next step, which I am going to highlight, or which I am going to write, is classes. Now, minimum value, students, is -10. But if I go the reverse way, one of the classes is 0 to 6, then -6 to 0, and -12 to -6. So -12 to -6. Then -6 to 0, 0 to 6, 6 to 12, 12 to 18, and 18 to 24. And last we have totals. That's all. Because the maximum value is 23. So we have prepared 6 classes. So if I go for frequencies 2, 5, 12, 10, 2, 5, 12, 10, then the 6, 5, 6 and 5. So this total comes out to be 40. You can check. So here classes, telemarks and FI. Classes are students change in production. I can write here change in production of mixtures, and these are number of days. Now, students, we have to go for less than time and more than time cumulative frequency distribution. Now, in less than time, we use upper boundary points, and in more than time, we use lower boundary points. This much all of you know. So, I am giving the title less than time cumulative frequency distribution of production of mixtures for 40 days. Now, the columns which we have to make are very, very important. Come on, tell me, students, which are the two columns we are making. Less than upper boundary point, less than upper boundary points, and corresponding cumulative frequencies. Upper boundary points. So upper boundary point starts from -6. We take a value before. So -12, -6, 0, 6, 12, 18, and 24. We start with minimum because less than -12 the frequency is 0. 0 plus 2 is 2. 2 plus 5 is 7. 7 plus 12 is 19. 19 plus 10 is 29. 29 plus 6 is 35. And 35 plus 5 is 40. So we start with 0 and students we end with maximum in less than time cumulative frequency distribution. Now here I am preparing more than time cumulative frequency distribution of production of mixtures for 40 days. I am giving title here more than time cumulative frequency distribution of production of mixtures for 40 days. Again, we have to make only 2 columns, but those 2 columns are very important. The first column will be more than or equal to. More than or equal to the second column is students corresponding cumulative frequency. Students, here also we write all boundary points. Minus 12, minus 6, 0, 6, 12, 18 and 24. Here we start with maximum. Go on subtracting one frequency, I mean to say 40 minus 2. 38, 38 minus 5, 33, 33 minus 12, 21 minus 10, 11 minus 6, 5, and here 0. So, in more than time, we start with maximum and end at 0. In less than time, we start with 0 and end at maximum. So, this is a lengthy sum. First, we are asked the cumulative frequency. First we are asked an original distribution. Based on original distribution, students, we are asked to prepare less than time and more than time cumulative frequency distribution. So, bit lengthy, but students, easy to understand. Now, the fourth sum of section F, students, we will do fourth sum of section F we are doing, students. Now the question is as below. The data regarding height in centimeter of 30 students of a school are as under. Prepare an inclusive check. Here we are told to prepare an inclusive frequency distribution of 6 classes and hence prepare less than type and more than type cumulative frequency distribution. Okay, students, here what is the highest and lowest value that we will locate first. So, answer for here XL and XH. Okay, what is the highest value? Then 168 and lowest 141. 168 is highest, 141 centimeter is the lowest. So range R is equal to XH minus XL. 168 minus 141. So 27 centimeter. This is the range. Then number of classes are 6. Number of classes are 6. So class length will be range divided by number of classes, 27 divided by 6. So it is 4 point. How much? Let us check. 4.5 exactly. Okay. 4.5. So we will roughly take class length as 5. C into K. 5 into 6 is 30, which is greater than or equal to 27. C into K greater than or equal to R must be always satisfied. Okay, we give the title Inclusive Frequency Distribution of height of 30 students. Of height of 30 students of a school. First is classes, telemarks and F5. Classes will be height in centimeter. Classes is height in centimeter, and here F5 is number of students. Now, students, pay attention. We are going to prepare inclusive. Lowest observation is 141, and I have to prepare how many classes? 6. So I start from 140. And mind you, class length is 5. So here, students, The first class will be 140 to 144, not 145. 140 to 144, 145 to 149, 150 to 154, sorry, 155 to 159, then 159 to 164 and 165 to 169. Then comes total. Because boundary points, students, whenever we have an inclusive frequency distribution, we require boundary points. When we prepare less than type and more than type cumulative frequency distribution, frequencies are 288, then students it is 462, 462, and total will be 30 students here and not shown. Now what are the boundary points, students? Pay attention. From lower limit subtract 0.5 and to upper limit add 0.5. So 139.5 to 144.5, 144.5 to 149.5, 149.5 to 154.5. That means, students, I am showing here. And erasing down temporarily the calculations for range and all that all of you have already understood. Boundary points are very important to be written. So, students, first you can say reiterating the boundary points. (139.5) to 144.5, 144.5 to 149.5, 149.5 to 154.5, 154.5 to 159.5, 159.5 to 164.5, 164.5 to 169.5. Now let us prepare less than type cumulative frequency distribution. Cumulative frequency distribution of heights of 30 students. Here we have to prepare only 2 columns that all of you know. The first column will be less than or equal to upper boundary points. Sorry, less than upper boundary points, and then corresponding cumulative frequency distribution. Sorry, not equal to, students. Equal to is always included in more than type. Let me prepare that also title wise. More than type cumulative frequency distribution of heights of 30 students of a school. Here also we have to prepare only 2 columns, and those columns are more than or equal to lower boundary points, NCF. Mind you, equal to is always included in more than. Now upper boundary point starts from 144.5, we take a value before. So 139.5, 144.5, 149.5, 154.5, 159.5, 164.5 and 169.5. Here also say 139.5, 144.5, 149.5, 164.5, 169.5. Equal to, I repeat, is again inputted in more than type. In less than type, we start, there is no value less than 139.5, so 0. Add 1 frequency, 0 plus 2 is 2. 2 plus 8, 10. 10 plus 8, 18. 18 plus 4, 22. Plus 6, 28. Plus 2, 30. Start at 0 and at maximum. Start with maximum. More than or equal to means all 30. Subtract 1 frequency. 30 minus 2, 28. 28 minus 8, 20. 20 minus 4, 16. Then 16 minus 6, 10. Then students, okay, 30 minus 2, so 28. 28 minus 8, so 20. We have, okay, 30 minus 2, 20. Again, 20 minus 8, so 12. 12 minus 4, so 8. 8 minus 6, so 2 and 0. So students, I forgot to subtract 8. 30 minus 2, so 28. 28 minus 8, so 20. 20 minus 8, 12. 12 minus 8, 12 minus 4, 8. 8 minus 6, 2, and 2 minus 2, 0. Correct, students. So, this are, you can say, the corresponding cumulative frequency distribution. And some questions are asked. So, very lengthy sum. And some questions are asked. On the basis of it, answer the following questions. If participation in the NCC activities require minimum height of 160 centimeter, then how many students are eligible for participation? Minimum height is 160 centimeter. So, how many students are eligible for participation, students? Then here also you have to count manually how many of them have their height, students, greater than minimum height required is 160. So how many students have their height greater than or equal to 160? So you can easily count also manually. I think the answer is 8 students. So answer 1 writing here. Answer 1 is 8 students. We will not be able to get from this frequency distribution, students. Okay, those having height means we can add this 6 plus 2, that is 8, but this will include 159.5. So students, pay attention. Sorry students, I should have written here 160. Sorry students, 160. Okay, so we can add this to frequency. Sorry students, it is 6 plus 2, 8. We will directly get the answer from this. By mistake, students, I wrote here 159. It should be 160 to 164 and 165 to 169. So number of students who are having their minimum height 160 or more, okay, directly we can add this to frequency. 6 plus 2, 8. Find number of students having height from 153 centimeter to 163 centimeter. This also you have to add manually. Number of students having height from 153 centimeter to 163 centimeter. Students, the number of students are 12. Answer 2. Height from 153 to 163 centimeter, 12 students. We have to count manually here. You have to count manually, students. Okay, be careful. Then, answer 3. Maximum height of 1/3 of the students having minimum height. Now this part of the sum demands attention. Students, find the maximum height of 1/3 of the students having minimum height. Now 1/3 of the students means 10. 1/3 of the students means 10. Check. Total are 30 students. So 1/3 of 30 is 10. So I have to draw. These 10 students are having minimum height. In that, what is the maximum height? Then the answer is 149. So the third answer is 149 centimeter. This is interesting, students. What is given? 1/3 of the students are having minimum height out of total 30. So total 30 students, 1/3 of 30 is 10. Within these 10 students, what is the maximum height? So these 10 students are within the class range 140 to 144 and 145 to 149. In this, the maximum height of a student will be 149. So third answer is 149 centimeter. A very lengthy sum, students. Very lengthy sum. So try to understand these, students. Here I apologize, instead of writing 160 by mistake I have written 159. Students, you change it afterwards. So this completes our section F in total. Students, it is a very lengthy section. We took almost 50 minutes to complete only 4 sums. So be careful that this type of sums are lengthy. So we conclude the lecture here, students. Thank you.